Hey guys, welcome to the next chapter we'll be covering, which is chapter 7 on multiplication properties of exponents. Multiplication property of exponents. Okay, so I've got some vocab and then we have our properties we're going to go through. So first off is the word monomial. Okay, and a monomial is simply a number, oops, don't want that yet, a number, a variable, or a product of a number and variable, you might remember from 6th grade and 7th grade that it's also called a term, okay? And it can have a positive integer exponent. Has a positive integer exponent. Now we will talk about some terms that have negative exponents, and we'll also talk about terms, monomials that have rational exponents. Yeah, that'll be a lot of fun. So let me give you some examples of our guys here. So we've got 2x is a monomial, 14ab squared c cubed is a monomial, 5 is a monomial, y is a monomial. However, a, b over c, this is not a monomial. And the reason why is because it says it's the product of a number and a variable, not a quotient. Okay? All right, so then let's remind you of another term you learned in 6th grade, which is a constant. And a constant is a monomial. That is a real number. So that means it can be a fraction, a decimal, it can be positive, it can be negative, it can be a whole number, integer, that whole group. Okay. So let's do an example. Okay. So the 3 is called the base, and the base is the number being multiplied by itself not by the exponent number, but by itself repeatedly. Now that repeatedly is dependent upon, obviously, the exponent, right? So that will take me up to the exponent, which is that guy. So exponent is, it tells how many times to multiply the base by itself. Okay? And then overall, if you look at this whole thing together, that's what we call a power. Okay? All right, so 3 to the 4th power means 3 times 3 times 3 times 3. So I stop when I have 4 3s. Okay. Now, again, this whole thing, it's all about a multiplication problem. It's a fast way of writing a multiplication problem with a repeating factor. If things should show up once, you're not going to do exponents. But if the factor is repeating more than once, then you can use exponents. Okay, so we've got two rules we're going to learn, and hopefully we'll get them both on the same slide. So that would be the product of powers. So this is the first property of exponents, product of powers. So let's say you have 3 to the 4th and you want to multiply it by 3 to the 5th. Well, what is that actually demonstrating? Well, 3 to the 4th is 3 times 3 times 3 times 3. And 3 to the 5th is 3 times 3 times 3 times 3 times 3. So if you take it all together, you have the same base 3 that shows up 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So if you think about it, when multiplying like bases, so that means the big number has to be the same, multiplying like bases, the fast way of coming up with the answer is look at your exponents were 4 and 5, and when you multiplied those two powers, you ended up with 3 to the 9th. 4 plus 5 is 9. So when multiplying like bases, you're going to add the exponents. Okay, and algebraically it would be written like this. If you have a to the mth power and you're going to multiply it by a to the nth power, so again we have the same base, you would add the exponents, would be a to the m plus n power. Okay, now we've got the next guy, and I'm wondering, should I go on? You know what? I think I am going to do him on the next slide, but it's still I think this whole set of notes could be done on one page, to be honest with you. So let me go to the next slide because I don't want to jip the space that I might need. So the next guy is called the power of a power. Okay, so let's talk about that. So power of a power. So not the product of a power, but a power of a power. So that would be something like, I want to take 3 to the 4th power and I want to raise it to this, I want to square it. So what does that look like? Well, 3 to the 4th squared means 3 to the 4th times 3 to the 4th. Well, now this has just become a product of powers, so we know we're going to add those exponents because we have 3 times 3 times 3 times 3, that times 3 times 3 times 3 times 3, and that gives us 3 to the 8th. So if you look at your original exponents and you look at what you get for your solution, we can draw a conclusion, and this is our conclusion. When raising a power to a power, so when raising with fraction and a fraction, or I mean exponent and exponent, and raising a power to a power, so exponent to exponent. If I did 4 times 2, that would give me the 8. So that's going to be the key thing we're going to do. We're going to multiply the exponents. Okay, and algebraically, this is what we would write. If I'm going to take a to the mth power and raise it to the nth power, I would get a to the m times n power. Okay? Let's see. Anything else I want to add here? Okay. Now, what can happen is we can end up getting some coefficients in our problems. So, a couple of asides. When multiplying powers with coefficients, and you'll see examples. Multiplying powers with coefficients. We're going to, multiply the coefficients, so numbers times numbers, but we're going to add the exponents. So whatever math is originally happening in the problem, we're going to do that math to the coefficients, but we're going to go a level down. And remember that multiplying is fast adding, okay? So that's why we go down to adding. And then, same idea. Let's do a different color. Let's do orange. So when raising a power to a power, hold on a minute. Raising a power with coefficients. To a power. We're going to raise the coefficient to the power as well. So again, we're going to do a demonstration of these. So we're going to get that coefficient show up as many times as the exponent tells us it would show up. So the directions we're going to hear are simplify, which means do all the math you can do until there's no more math to be done. And let's do 6n cubed times 2n to the 7th. So first thing I'm looking at, and I can always do this, is I can always take the coefficients and I can multiply them. Now this is a multiplication problem, so remember when I multiply like bases, then I'm going to add the exponents. So shortcut way, this is what my brain is thinking. I'm going to get the variable n, and the exponent will be 7, or 3 plus 7. So altogether, I get 12n to the 10th. Okay. Let's have 3pt cubed. And I want to raise that, or not raise it, multiply it by p cubed t to the 4th. Okay. Now, I need you to remember this. P is the same thing as p to the first power. Super important you see that. Okay. So we're going to do what we did before. Let's see, I have 3, and the coefficient on the second power is 1. So we're going to do 3 times 1. Now on the p's, again, when I don't see the exponent, it is 1. And then we're going to add it to 3. And then on the t's, we have 3 plus 4. So that's me using my rule. And I get 3 times 1 is 3. 1 plus 3 is 4. 3 plus 4 is 7. So my final answer is 3p to the 4th power, t to the 7th power. All right, let's do some powers to a power. Let's do, we're going to take 2 cubed. We want to square it. And then we want to take to the 4th power that whole thing. Okay? So we're going to take 2 cubed, and we have power to a power, so we're going to have 2 times 4. So if I simplify that, I get 2 cubed to the 8th power, which is now going to be the 3rd power times the 8th power. So I get a total of to the 24th power. Now some of you may say, hey, wait a second, couldn't I have just done that in one step? The answer is yes. What you could have done is 2 to the power times the power times the power. And that's going to give you the same exact answer. Pretty cool, huh? All right, last one. This is our doozy. So I'm going to give myself a little bit more room up here. So we're going to take 3xy to the 4th, and we're going to square that, and then we're going to multiply it by negative 2y. That's going to be squared, and we're going to cube the whole thing. Holy smokes. All right, so here's what we're going to do. And I'm going to just break it out by part. So I'm going to take the coefficient, and I'm going to raise it to the 2nd power. I'm going to square it. I'm going to take the x, which, by the way, has an exponent of 1, and I'm going to square it, which means I'm going to multiply the exponents. And then I have y to the 4th, and I'm going to square that. Whew, this next one gets real interesting. So I'm going to start with the negative 2, and I'm going to square it. And then I'm going to take the y, which has an exponent of 1, and I'm going to square it. And that's all I could do for the moment. So let's see what I can do in the first one. I can square 3 is 9. 1 times 2 is 2. 4 times 2 is 8. So that first monomial is done right now. Second monomial. Negative 2 squared. So negative 2 times negative 2 is positive 4. So an even number of negatives is going to give me a positive. I'm going to write that over here. I like that idea. Even number of negatives when multiplying that's going to be a positive answer. And then, sorry, not even, odd. An odd number of negatives when multiplying you always have one extra odd, so you'll have a negative answer. Okay, all right, so back to the problem. So negative 2 squared is 4, and then we have y, 1 times 2 is 2. But we still need to cube that guy. So 9x squared, y to the 8th is just hanging out for a little bit. And then we're going to get 4 cubed y squared cubed. So let's do that. And we get 9x squared y to the 8th. And I'm going to change this to parentheses now. So 4 times 4 is 16. 16 times 4 is 64. And 2 times 3 is 6, so y to the 6th. All right, so now let's see what we get to do. So here's kind of the brain step. I'm now going to put the coefficients together, 9 times 64. And then look what happens with your exponents. I have 2, and I'm going to put something here just so that you'll understand it. Look at what is the x's on the second monomial. There aren't any. So you're actually going to add 0. So the exponent 2 is going to stay the exponent 2. Now on the y's, though, you have 8 from the first monomial and 6 from the second one. Okay, so I'm just going to do 64 times 9 off to the side, so I make sure I get it right, and I get 36, and then I get 54, 55 to 6, 57. So I get 576 x squared y to the 14th. Voila. And there you go. All right, good luck with this, guys. Bye now.